Hello and welcome to this video tutorial on using the dplyr package. So this is the first time I've done a video focusing entirely on a single package, but dplyr is extremely useful for subsetting, transforming and getting summary statistics for your data much more easily and quickly than you could do using the base R commands. So let's start by installing and loading dplyr into memory. So if you haven't installed dplyr before, then we use the install packages, dplyr, which I won't run because I've already installed it. It may take quite a long time to install, so you might want to pause the video now while you install the package. And then when the package is installed, we're going to load it into memory using the library function, dplyr. And then for this tutorial, we're going to load in the mtcars stock dataset that's available in R. Okay, so the dplyr package has a large number of functions which are extremely useful for exploring your data. We're not going to cover all of them, but we're going to cover probably the 6 most important functions in the package that I'm going to refer to as dplyr's verbs. So these are select, filter, arrange, mutate, summarize, and group by. So these are the 6 most useful functions in the package. And you'll notice that they're all verbs. They're all sort of describing an action that we're going to perform, which is useful for remembering which one does which task. So we're going to start by using the select function. And quite simply, the select function takes the data frame as an input, and then any columns which you want to return from that data set. So it's a way of filtering or subsetting columns. So the first argument is the mtcar. Actually, let's remind ourselves of what the mtcars data set looks like. So we have a data frame where each row corresponds to a vehicle, and then we have columns, miles per gallon, number of cylinders, displacement, horsepower, etc. So let's say we were only interested in looking at the horsepower column, or we wanted to subset the horsepower column. Then we supply the first argument of the select function as the data frame, and the second argument is the horsepower column. And now it's returned the data frame with just our horsepower column and the row names. If you want to select more than one column, let's copy and paste this, then you simply supply them as additional arguments. So let's say that we want horsepower, we also want miles per gallon and the number of gears. And if we run Control Enter, then again we get our data frame, but just with these 3 columns that we've specified. And we can also do this using the column index. So for example, if we wanted columns 1 through 7, then we can supply this as an argument, and then we get our data frame with columns 1 through to 7. If we were using base R to do this, we would do it something like this, which gives the same result. We'll find out a little bit later on that one of the benefits of using the select function within dplyr rather than the base R. Well, one is that it's a little bit more verbose. It's sort of a little bit in more plain English exactly what we're doing, and also you can chain dplyr verbs together to perform more complicated operations in one go, and we'll explore that a little bit later on. So that's how we select and subset individual columns. What if we want to subset and select individual rows? And so for this we use the filter function. So we use the filter function. The first argument is again the data frame that we're working with, and then the second argument is how we tell filter to select which rows to return to us. And so this is usually a logical expression which filter will evaluate for each row and decide whether to return it back to us. So for example, we may want to return just the rows for which the weight variable is greater than 3.5, and if we run this, then we find that we get every column in the original data frame returned to us, but only the rows for which the weight variable is greater than 3.5. If we want to filter by more than one condition, then we just apply these conditions as additional arguments. So empty cars, weight again greater than 3.5, and let's say we also only want to return vehicles for which the weight is greater than 3.5, and carb variable is exactly equal to 4. And then if we run this, again, all of the columns are returned, but only the rows for which satisfy these two conditions are returned. So the filter verb is a way for returning only those rows that satisfy certain conditions that we're interested in. The third verb is arrange, which is extremely useful when you want to put your data frame into some kind of order dependent on the variables. So let's say we want to arrange our empty cars dataset by the gear variable. And now our entire data frame has been returned, but all of the rows have been ordered such that the gear variable is listed from low to high. If instead we wanted to arrange or order our data frame such that they're ordered from high to low gear, then you simply put a minus sign in front of the column that you want to order by. And if we run this, then this time we find the low gears at the bottom and the high gears at the top. Now, just like the other verbs, if we want to arrange our data frame by more than one variable, we simply supply these as extra arguments. So let's copy this and paste it again. So let's say we want to arrange by carb. Let's put that in descending order, and then also weight in ascending order, and then we run Control and Enter. And this time it's important to note that the data frame is first ordered by the first variable that you supply. So it's been ordered from in descending order with gear from 5 gears to 3 gears, and then within each level of gear, we've ordered our rows by carb. So you can see within 5 we're going from 8 to 6 to 4 to 2 to 2, and if there are ties, then we find that the weight variable is used to break those ties, where weight is in ascending order. Okay, so you can use the arrange verb to order the rows of your data frame in a meaningful way. The fourth verb is mutate, which sounds a bit funky, but we basically use this to create new columns from existing columns in our data frame. So it might be that we want to transform a variable and save it as a new variable. So the function is mutate. First argument is the data frame. The second argument is the name of the new variable that we're going to create. So we're going to divide the weight by the number of cylinders, followed by an equal sign, and then the definition of the new variable. So we're going to take the existing weight variable and divide it by the cylinder variable. And if we run this, we get our entire data frame returned. But now I hope you can see that we've got a new column, a new variable, which is the result of dividing weight by the number of cylinders. If we want to perform or generate more than one new column at a time, we can do this. So let's just copy and paste this existing command. And what's particularly cool is that we can actually define new variables based on the variables that we've created in the same function call. So I'm going to create a new variable called the inverse weight cil, and this is going to be equal to 1 divided by weight cell. So in this one function, mutate is going to take the empty cars data frame. It's going to create a new variable called weight cell, which is going to be equal to the weight variable divided by the cylinder variable. And then in the same function call, it's going to take this variable, divide it by 1, it's going to take 1, divide it by this variable that we've just created, and it's going to call it inverse weight cylinder. So we don't have to do this in two separate function calls. And so if we run this, we have our entire data frame with our two new variables, weight cell, and then the inverse of this weight cell column. One important thing to mention is that these variables have not been saved onto our empty cars data frame. So if I call empty cars, these variables are not there. So if you call the function just like this on its own, it'll display these variables for you, but they won't be saved. So what you should do is save your mutate call to a new data frame. So for example, empty cars 2. And then if we call empty cars 2, now we see our new weight cylinder variable that was defined by this function. Our fifth dplyr verb is summarize. So summarize is useful for generating summary statistics from your data frame that you can define in any way that you like. So we start with the summarize function. The data frame is empty cars. And then the next argument is the name of the summary statistic that you're going to produce. So we'll call this min HP. The equal sign, and then the definition of how this statistic should be calculated. So this is sort of similar to in the mutate function where we defined the new variable, the equal sign, and then how the variable was going to be defined. And I want this statistic to be the smallest value for the horsepower variable. Now when you're exploring your data, it's useful to look at lots of different summary statistics to get an idea of how your data are distributed. And we can define these additional statistics by separating them with commas. So let's define a second one called average horsepower. And this is equal to the mean of the horsepower variable. We'll go max HP. I hope you can see where this is going. It's going to be the maximum HP value. Let's go onto a new line to make it a bit easier. Med HP is going to be equal to median HP. And then finally, the IQR HP is equal to the interquartile range of horsepower. And now if we run this whole function, we get the summary statistics that we've asked for defined across our entire data frame. So we get the minimum value for horsepower, the average, the maximum, the median, and the interquartile range. And we could have gone on defining summary statistics if we wanted to for each individual variable, but these are the ones that we've defined for now. Now, this might have seemed quite a lot of work to get summary statistics out of just one variable in our original data frame, the horsepower variable, when you might be asking yourself, actually, well, why don't we just use the base R summary function, which gives us all of these summary statistics and more for every single variable in our data frame. And you'd be right, it's much easier to just type this and get summary statistics for every single one of our variables than to type this just to get summary stats for a single variable. The summary function gives us summary statistics across our entire data frame, ignoring group membership, because we haven't informed R that we want statistics based on individual groups. So for example, you may have subjects belonging to 3 different treatment groups, and you want these summary statistics for just those 3 groups, so the summary statistics within the groups. And we can combine summarize with the final verb that we're going to talk about from the dplyr package, which is the group by verb. So the group by verb does pretty much what it sounds like. It will partition our data frame into rows which have membership to particular groups of a grouping variable. So let's take our empty cars data frame, and the second argument is the name of the variable that we want to group by. So we'll group by gear. If we wanted to, we could group by additional variables. So for example, if you had an experiment which was factorial, so you had people assigned to placebo versus drug treatment, and then within each of those you stratified by men and women, for example, you could group by drug treatment and then by gender, so that you would end up with 4 different partitions of your data. We're just going to group by the gear variable, and we're going to save this as a new object called grouped. And now this is where the power of the summarize verb comes in, because if we copy and paste this summarize function call from up here, paste it down here, and instead of applying this function to the whole empty cars data frame, we're going to apply it to our grouped data instead. And now if we run this, we find that we get our summary statistics as we've defined, so our minimum, average, max, median, and interquartile range, stratified for cars which had 3 gears, 4 gears, or 5 gears. And so it's a very nice way of getting summary statistics for certain groups of data. Now I mentioned that we can group by more than one variable, so let's create a new object called grouped2. We're going to use the group by function and apply this to empty cars, and we're going to group by gear and the number of cylinders. And now again, if we just copy and paste this summarize function and apply it to our grouped2 data, we get our summary statistics as we've defined them at each combination of gear and cylinders. So this is particularly useful at getting summary stats for combinations of grouping variables, which actually doing this in base R is a lot more involved. Now those are the 6 main verbs that I wanted to talk about in dplyr, so I hope that you can see that they're useful in selecting data, transforming data, and summarizing your data. But actually there's one powerful tool that comes with dplyr which makes these verbs even easier to use, particularly when you're stringing them together, and that is called the pipe operator, which is a percentage sign followed by the greater than sign closed off by another percentage sign. So what does this mean? It means take the argument on the left hand side, or take the object on the left hand side, and pass it into the function on the right hand side as the first argument. So let's see this in action. So let's take the empty cars data frame and pipe this into the group by function, and we're going to group by gear. So what's going to happen is the pipe operator is going to take this object, the empty cars data frame, and pass it to this function as the first argument. So this is the equivalent of writing okay. So instead of putting the empty cars as the first argument, we simply pipe it in to the first argument position using the pipe operator. You may be thinking that this is a lot simpler than this, and for this case it is, but when you want to string multiple operations together, as we'll see in a second, piping in to functions becomes very useful. So this has the effect of grouping the empty cars data frame by gear. Well, now let's take that grouped data and pipe it into a summarize function, which will report the median weight. And so now what's going to happen is the empty cars data frame is going to be piped into the group by function, which will group it by gear. And then this grouped data will be piped into the summarize function, which will produce the summary statistic median of weight for each level of gear. If we weren't using pipes, this would be the equivalent of typing which is slightly shorter in terms of code, but I hope that this is a little bit easier, in which we say that we start with our data frame, we perform one operation on it, we pass this to the next operation, and if you read the pipe operator as sort of saying "and then" in your head, I find it a lot easier to keep track of exactly what I'm doing. So take the empty cars operator, the empty cars data frame, and then group it by gear, and then summarize it by taking the median of the weight. And so when you're stringing multiple operations together, it can be much clearer and easier to use the pipe operator. And actually, to make it even clearer, the sort of standard practice is to separate these operations onto different lines so that you run through them from top to bottom. So for an example, let's make a new object called subset. Actually, let's call it subset cars, because subset is a function. And we're going to start with the empty cars data frame. We're going to pipe this into, and then we're going to go onto a new line. We're going to select columns 1 to 11. Oops, no, we're going to select columns 2 to 11. We're going to pipe these selected columns and filter them to pick out just the rows which satisfy the condition that the weight is larger than or equal to 2. And then if we run this, we'll call subset cars, then we have a data frame with the columns that we selected and only the rows which satisfy the condition that the weight variable is larger than or equal to 2. So the fact that we start with the name of our data, and on separate lines we perform separate data selection functions or data transformation functions, makes it easier for us to sort of read from top to bottom exactly what we're going to end up with. Well, let's go a step further. Let's create an object called ranged cars, because we're happy with the data that we've selected in our subset cars data frame, but actually we want to order them in a particular way so that it's easier for us to see if there are any meaningful relationships in the data. So we're going to start with subset cars. We're going to pipe this into a group by function, and we're going to group by gear and cylinder. Then we're going to pipe this into a mutate function to create a new variable. And like earlier, this is going to be the weight divided by sil. And this is going to be piped into an arrange function where we want to arrange the entire data frame based on this weight sil variable. If we run this and call arranged cars, then you can see we've got our new variable, and that the data frame is arranged such that this variable is in ascending order. Don't worry about the fact that this looks slightly different from our usual data frame. dplyr likes to turn data frames into what it calls Tibbals, which are a slightly different way of representing data, but for the most part they're very similar to data frames in that they have rows of data and columns of variables, and so most of the time you can apply the same functions to both of them. And then finally, let's pipe our arranged cars data frame into a summarize function where we just want the, so you don't actually have to name the variables. So let's not name one. We'll just ask for the standard deviation of this new weight cylinder variable that we've created. And then because our data frame is still grouped, we get the standard deviation for the weight cylinder variable at each level of our groupings. So dplyr has a lot more useful functions in it. These are the sort of the bread and butter that I think most people can use to quite quickly subset, explore, get summary stats for, and transform their data. So play around with it on your data, particularly using the pipe operator, which if you're performing several steps of data selection or transformation, makes it much easier for you and other people reading your codes to keep track of exactly what you're doing, and sort of allows you to express these operations in plain English. So I hope that was useful. I will see you in the next video.